Hello, and welcome to the replay of the Dalet Academy IMF webinar. My name is Bruce Devlin, and this is part of the Dalet Academy webinar series. It's brought to you through our training resources, where we hope to give you lots of white papers, the Bruce's Short series, webinars, and a whole bunch of free stuff to help you do your jobs better and help you remember the Dalet name. So, what's this webinar all about? Basically, today it's all about IMF. Why does it exist? What's it mean? How does it work? We're going to focus on IMF application 2 and then come to some conclusions, I hope, about what we can do with IMF going into the future. So let's crack on. Firstly, a big thank you to all the folks at the Academy who've helped me put this webinar together, and also thank you to SMPTE and their standards work that's actually helped create the IMF in the first place. And if you're not a member of SMPTE, I recommend that you do become a member, join in, especially if you think that IMF is going to be important to your future. You get to control what IMF does. So let's talk about IMF, the Interoperable Mastering Format. What problem is it actually trying to solve? Well, imagine that you've got some content and you want to get that content out to a number of different platforms, whether it's on disk or to a broadcaster or onto a gaming platform. How do you get to those revenue generating distribution platforms from your source content? Well, anybody who's thought about this will first build a factory, and that factory will then create a number of different mezzanine variations, and those mezzanine variations will then be delivered, hopefully via some automated process, to those end deliverables. All sounds fairly straightforward, apart from the fact there's an awful lot of them. So if you're building one tape or one complete asset for each of those deliverables, you're actually chewing up an awful lot of disk space, an awful lot of resource, and there's an awful lot of management overhead trying to remember how you made each individual version. But don't forget that the world is actually quite a big place. As well as those different technical variants, you also have a number of different compliance or language variants or subtitled variants to deliver to all of those different places in the world where you want to generate revenue from that content that you've made. But more than just different places in the world, there's also different places within a territory where you might, for various revenue generating reasons, create slightly different variants, either to optimize local advertising or to optimize the ending, because certain places like happy endings, sad endings, or there might actually be different state rules that mean that you can't have certain scenes or certain words in different versions of your content. And that problem is more than just the final end delivery problem. It's also a problem of how you actually push all of that content through your production chain to actually make all those different versions in the first place. From the original film, video, captioning, and recordings, you've actually got an awful lot of little bits of asset that you need to manage to generate each of those intermediates, and from those intermediates generate the final delivery resources that you want to ship to your final multi-platform distribution system. So the problem really that IMF is trying to solve can be boiled down to making efficient masters that can be efficiently automated at various different timelines, various different resolutions, different aspect ratios, different languages, different technical deliverables, to make all of those different video, audio, caption, and metadata bundles. We want to have a common, preferably standardized format that you can use to drive those pipelines and to interchange between production houses, post-production houses, and put into vendors' equipment, such that you're trying to get cost out of the system and to optimize that delivery chain so that you can create better programs and really put the money where it's needed into those creative processes. So IMF is designed as the Interoperable Mastering Format to be one format from which you can generate multiple different versions. The goal is to minimize storage and maximize the reuse of components. And we do this by storing deltas, storing just the differences between the main versions and the different supplemental versions which describe the differences, for example, between the French version of the movie and the German version of the movie and the main English version of the movie. We need flexibility because at the end of the day, we're delivering entertainment. And what's entertaining in different territories could be quite different. So we need to be flexible in how we define the entertaining different variants of the movie or the documentary or the sports clip that we're trying to do. We're trying to drive automation downstream. So we need to be cognizant of that fact upstream, that we need to be generating metadata that allows automated downstream processes. And most importantly within IMF, we don't want to reinvent any wheels. There's a lot of good wheels out there. So IMF is very DCP-like, digital cinema packaging-like, and it's also very ASO2-like. And effectively what IMF has done is to take the best things from the digital cinema community, the best things from the ASO2 community, and bundle them all together and try and make something that really is optimized for this multi-version, multi-platform world in which we're living. And if we can use IMF to manage and optimize our workflows, then we stand a very good chance of having a good, workable economic solution that's got sufficient long life that manufacturers will build software and products that allow production and post-production houses to create content in IMF and allow the content owners to use IMF for the reason it was designed, which is basically to create interoperable masters. So how did IMF come about? Let's have a little delve into some of the history of it, shall we? Once upon a time, I ran a project called GeForce, the generic format for storage. And that eventually fed into ProMPEG Forum, which was looking at how do we move MPEG around the place, which had about 300 participating members that eventually formed 377-1, the MXF standard. And if you remember, if you were around back in those days, MXF was supposed to be the format to bind them all. It was the format for the industry, by the industry, that was going to solve the interoperability problem. And in a way, it did, because we made a fantastic toolbox. What we didn't really do is define what applications that toolbox had to solve. There were many different MXF formats that got created back in 2004. And really between sort of 1999 and 2004, a lot of the input to MXF was coming from technologists who were trying to solve problems. And a lot of the requirements came from end users, but there wasn't really a coordinated group trying to look at what were the actual business problems that the MXF technology had to solve. So there are a number of different activities that took place around that time. And one of them was the studios under the guise of the ETC, the Entertainment Technology Center, talking about mastering mezzanines. In parallel, there was a group in the TV world developing a standard called ASO2, and they shared some very common roots, that the idea was to store components and have individual components that you could push together to make different versions. In 2008, the ETC really got together in earnest and started publishing some of its work about the digital video package, as it was called then. And fast forward to 2011, and the version 1.0 of the IMF specification got published. In fact, there's a press release still on the ET Center website if you want to go and have a look at it. A month later, IMF landed in SMPTE, and SMPTE looks at standardizing IMF. In 2015, when I recorded this webinar, many parts of that standard are now published, and there's a nice wall chart available that shows you who's contributing, what the different parts of the standard mean. And actually, we'll take a bit of a walk through what those bits are here so that you can figure out what's going on. And those links, by the way, I'll try and make those available somewhere on the Dalet website so that you can find those. Now, the wall chart's very lovely. You can get a copy of it if you're a SMPTE member. Becoming a SMPTE member also means that you can work on IMF and you can make IMF just right for you. And the reason that IMF features the phrase application 2 up at the top is because IMF is looking at that business problem of making an interoperable mastering format. We've already gone through some of the drivers for it. But there's more than just one application within that global space. And application 2 is really looking at the use of JPEG 2000 as that interoperable master. There may be other compression formats you want to use, and there might be other things that you want to do, which might be 3D, 4D, 5D, ND, or something like that. And those would be different applications. So this chart that you can get from SMPTE goes through some of the major details and the major bullet points. Thoroughly recommend it. There are other IMF resources available to you. If you're a SMPTE Standards member, all of the standardization is taking place in the 35PM group. And particularly here in 2015, one of the groups that's very active is the SMI group, the Sample Material Interchange group. This is where the software and hardware vendors are getting together to interchange their IMF bundles to make certain that when the products hit the shelves and people are ready to really roll out their IMF workflows in earnest, that we're not competing as in terms of whether we interoperate, we're competing on the functions that we add using IMF as the core. And that's really key to getting these standards rolled out well, is that pre-charging the marketplace and pre-charging the workflows by some serious investment on behalf of the software writers to actually get the software to work before the products really get deployed widely. There's also a couple of excellent SMPTE professional development webinars available, one for SMPTE members and the other available to everyone. Thoroughly recommend having a look at those. There's also the imfforum.com, which is a place where public IMF information and Q&As get published. And there's also a registry open source project that's been published on GitHub, written by the very excellent Pierre Lemieux, and it's based on some of the underlying SMPTE registers. Those underlying SMPTE registers contain all the magic numbers and magic metadata that allows you to describe essence, and those really are the building blocks that IMF uses to build these applications and application specifications. So thoroughly recommend having a look at that. Right, so that's kind of the preview. How does IMF actually work? Well, let's have a look. So IMF is a bundle of components, and those components comprise the video and audio, the actual essence files, and those live in individual track files. So if you've got ordinary video, that'll be in a video track file. Stereo audio, you'll find that in a track file. If you've got surround sound, you'll find that in a track file. If you've got Spanish dialogue, that'll be in a track file. So all the separate bits, all the separate components will live in their own track files. It's important to realize that things like captions and subtitles, those are actually data essence. That's not metadata, that's actually data essence. It's creatively created by a creative person doing creative tasks. It's essence. So those live as data track files. And within IMF, the standard for captioning and subtitles is time text markup language from the W3C, that's TTML. And the profile of TTML that's being used is IMSC, the Internet Media Subtitling and Captioning Standard, or profile. All of that's available by searching Google. You can find lots of information about that. There's also dynamic metadata available. There's ways that you can put metadata into your MXF so that you can use it in your compositions. Today in 2015, there's not much of that being used, but as we move into a high dynamic range world and a broad color spectrum world, and as we start to have much more sophisticated workflows, we'll be seeing a lot more of dynamic metadata appearing in the workflow. Today, probably the only dynamic metadata that you'd find would be some kind of metadata vanc track. Then you've got some extra metadata that binds the whole thing together. There's a thing called the composition playlist, or the CPL. You can think of that like a super complicated EDL expressed as an XML document. It basically says which of the track files appear on the timeline at what moment and how are they synchronized and offset against each other. And you can think of this as one of the axes of controlling the complexity of generating versions. So the timeline axis is a very specific axis. For example, if you're doing a French version of a movie, you might overlay some of the street signs. So instead of saying butchers, it might say boucher, or just to try and localize the movie a bit, to try and make it more impactful in the territory in which you're distributing that movie. So those sorts of things, those timeline changes, that's the CPL. In addition to that, we have an OPL, the output profile list. That is a way of describing the way of mixing different audios together or adjusting color spaces, so that you take the raw essence and render it down to a different format for a specific deliverable. And that's, again, there's some pseudo creative decisions there, and all of that exists in the OPL. So the next component to add on to that is the way of binding it all together to create a packing list and an asset map, which are effectively there to tell you whether or not you've got all the components in the file that you wanted. So if I'm going to deliver my master package to a post house to actually generate all my multi-platform distribution essences, the packing list maps all the different file names to the different UUIDs for all of the CPLs and OPLs. So the packing list is like an inventory to tell you everything's there, and the asset map contains a map of different versions. The asset map's not used quite so much. The packing list is the main thing. Now, the important thing about all of these documents is that they all have signatures within them to make sure that you have the right version of the right file at the right time, and that it all binds together. It's quite important to remember that the IMF concept is all about having the metadata tie all of the essence and timeline and transcode profiles together. We try really hard not to use file names inside IMF bundles. The only time you'll see file names is in the packing list. And the idea of IMF is that by the time you've ingested it or put it into a system, it's really going to be managed by a MAM or some kind of inventory system. You could do it locally by scanning all the PKLs, but really it's designed to scale and grow big and complicated for very highly sophisticated bundles. And having a MAM is going to make life very, very simple for you. So that no file names thing can be illustrated quite easily by looking at an actual CPL. So those of you who speak XML will find this no surprise at all. Those of you who don't speak XML, I've highlighted down at the bottom here in big red numbers where it says track file ID. So the CPL, if you remember, defines the timeline. It defines which track file is going to be played at which time, how you synchronize them all together. And there are no file names in there. There is just a track file ID. And that track file ID links to that ID in the packing list. And the packing list then maps that to the original file name. Now, at the point of interchange, the packing list tells you that was the file name that corresponded to that UUID at the point of ingest. Once the thing's been on disk for a little while, there's nothing to stop you changing all the file names, providing you track the UUID to file names using some sort of asset management system. And you can move them around, put them on different disks, stick them on a tape, and do those usual sorts of asset management things that you do when you're running a busy facility and need to move files and hierarchically store them for later. The UUIDs are your friends. Don't be scared of them. Don't be worried because there's no file names. The UUIDs will actually make your life simpler. So let's go through some nice, simple examples to try and help you see how and why this structure exists. Oh, and for those of you who really like to be low level, those 16 bytes also happen to be the last 16 bytes of the MXF top level file package UMID. And if you don't know what that means, it's time to go and dig out one of my old webinars about MXF, or drop me an email to academy@dalet.com, and maybe I'll bring the MXF webinars up to date. So, the food analogy. You'll find in many IMF presentations and webinars that we use food analogies quite a lot. I'm a cyclist. I love to use food analogies because it always makes me hungry. So if you want to make great cakes, i.e. great TV content, you need great ingredients. And those ingredients are available to you in their raw form. Now, if you went down to the supermarket and bought loose flour and loose sugar and loose butter and had to lift your chicken up to get the eggs and loose currants, it's really quite difficult to manage all of those different ingredients because each one of them requires different handling and managing rules. And the same is pretty much true for media. The video and the captions and XML documents, they all need different handling rules. So one of the things that we do in IMF is we ensure that we have consistent wrapping on all of the ingredients and all of the essence so that we can handle all of the essence in the same sort of way. Just the same as when you go down to the supermarket, even though the packaging looks a little bit different, they've all got a barcode on, they've all got the weight on, they've all got the calorie count. So there are some standards in the way that we package things to make life more convenient. A modern supermarket really wouldn't work very efficiently if all the ingredients that you were selling were always sold loose. You'd have a very high labor content and you'd always be doing remedial fix-ups to make it work. And the same is true in the media world. If you have consistent, reliable packaging, you stand a much better chance of having good automation. So once you've got your ingredients packaged well, you then need some recipes. Those recipes tell you how to put the ingredients together so that you make different variations of the same thing. So here we've got different fruitcake recipes. And you'll note they all basically use the same recipe. Some might have a little bit of extra clove, a bit of different spicing, slightly different ratios of the content, but at the end of the day, they're all making fruitcakes. And what's important is that these fruitcakes are targeted towards a specific cultural market. The Japanese fruitcake probably sells better in Japan. The Black Forest fruitcake probably sells better in the Black Forest in the heart of Germany. And cultural differences are the same for entertainment. If you adapt your movie or your sports program culturally to fit the audience, there's probably going to be more people watching it. And the recipes correspond to the CPL. It's like, how do you modify and put the different bits of essence together and get the timeline right for that target audience? So the recipe corresponds to the CPL. But you can then modify how that recipe is presented. And this is the output profile list. So I can make a square cake, I can make a round cake, I can embellish it, or in my personal particular case, I can burn the cake and probably nobody will want to watch it. So the way in which you package and deliver and present that final output is a bit like the shape of the baking tin and how you actually do the final baking, and that's what the OPL is supposed to provide. And the CPL and OPL together provide you two different axes for controlling those multimedia outputs. And if you think about it, having the two different axes does a wonderful job of complexity limitation. If you only had the one axis, you would have a very large number of configuration files. Imagine that you had, say, 3 different timelines and 4 different deliverables. 3 times 4 is 12. That would give you 12 different CPL-OPL combinations if you hadn't split it into 2 different axes. Whereas 3 plus 4 is 7. So 7 OPL and CPLs deliver 12 different outputs. And as the numbers go up, the difference becomes much more startling. If you had 10 different OPLs and 10 different profiles, at this point, that's 100 different combinations compared to 20 different files being stored. So CPL and OPL are there for complexity management, and there to make certain that the recipe can be targeted to a specific region, or a specific domain, or a specific business purpose, and you can bundle that recipe together and present it in the right format, in the right way. So let's pull all of that together. The ingredients are the different track files, the recipes are the CPL, and the baking tin, if you like, is the OPL. To really push that home, let's have a look at some specific examples. Let's imagine that we're making a master version of some English program. Here I've got a CPL that says I've got the title sequence, followed by the main video sequence, followed by the end credit sequence. And I've got an English stereo audio, and I've got some captioning. All of that together goes into my English IMP, my interoperable mastering package, and that I would deliver, if you like, as my baseline for my program. So having made our mastering package, why don't we now make a version of it? Imagine now that we wanted to add French to that version. We might have exactly the same video sequence with the same English title, English main video, and English credits, the same English audio, but now what we want to do is to add French subtitles. To do that, we simply create a French subtitle track, a TTML file, wrap it in MXF using SMPTE 410, and hey presto, we have a French version. So what do we actually deliver? Well, at that point, what we do is we package up just the differences. And this would be known as a French supplemental package, where we just have the French subtitles, we have an OPL and a CPL, and we reference the original English interoperable mastering package. Remember that everything is linked together via UUIDs, so it doesn't matter when I've ingested my English imp in my local system that I've changed all the file names for convenience. Those UUIDs will still match, even though the French subtitles supplemental package may arrive at some considerable time after the original imp. So let's make things a little bit more complicated. Let's now add some French audio, and we're going to put some French titles, some French credits, and we're going to give credit to the French dubbing artists as well. We've now got a new audio track in an MXF track file with the French audio in it, and we've got the original French subtitles. We create an OPL and a CPL to describe all of these new components, and we create a PKL and an asset map that binds the whole lot together, and at the point of interchange describes the file names and the UUIDs that form the whole package. Now, if you look at the size of this particular package, we've got a short French title sequence, a short French credit sequence, a short French dubbing sequence, and some audio. Even for a long movie, we're talking about megabytes of content here, not gigabytes or terabytes of content. Compared to the original IMP, which is probably gigabytes, many, many gigabytes, we're actually now in a situation where we're able to ship and move supplementals, which are quite small and quite efficient, yet through the signatures and the UIDs that exist within the CPL and the OPL and the PKL, all of these things are tightly linked together, and we can know when we receive it that we've got the right content for the right version at the right time. So what is IMF Application 2? What else do we have to specify on top of what we've just presented to make it all work? It's worth having a little bit of a look at the actual IMF specification structure. What we've been talking about are some of the IMF core constraints. We've talked about CPL, OPL, the packing lists. We've talked about the concepts behind how it all fits together, the food analogy. The core constraints also look at how you MXF wrap essence. That's the bit that was taken from ASO2. How you label audio to say what language it's meant to represent. There are some rules that say you've got to have homogeneous essence in a composition. You should have the same video resolution and the same frame rate, and that the edit rates of all the packages should be the image frame rate. All these things that just make life easy for the decoders and lead to better interoperability. The audio track file should be a single sound field group. In other words, it's the stereo group or the clean mix and effects. It should be 48 kilohertz or 96 kilohertz, but you don't mix them together. And that the captions and subtitles should be TTML constrained to the IMSC1 profile. So that's the core constraints. That's everything that's IMF has to meet those. Now, each of the individual applications basically plug into that core framework. And that's where we specify the codecs, we constrain the resolutions, the frame rates, and here we're solving specific problems for very specific interoperable mastering applications. And very quickly, Application 2 more or less covers the use of JPEG 2000 as a codec up to HD resolutions. Application 2 Extended is JPEG 2000 up to 4K resolutions, wider color space, all those UHD things that are coming along. Application 3 is very similar to Application 2 Extended, but uses the SSTP encoder. And Application 4, at the time I'm recording this, is being worked on and hasn't been published, so I'm going to have to stay silent about that because SMPTE's rules say that if it's still in standards, I can't tell you what's going on. And at this point, somebody says, Bruce, whatever happened to application 1? Well, because of SMPTE's rules, I can't tell you that. You're just going to have to join SMPTE and find out. So let's have a look at what we have to do to make application 2 actually work. What is the role of the OPL? What does the OPL actually do in 2015? Here is a series of OPL macros chained one after the other that get applied to the picture as an OPL chain. So for example, imagine that our J2K, this is application 2, imagine that our J2K essence was in RGB color space. The first thing that I need to do is to decode those pixels. So I need to know how to decode RGB and get them into some color space that I'm going to use. So there's a decode pixels color macro that essentially tells you that. Then I need to scale the pixels. For example, if my output is going to be SD or HD, I need to know how I'm going to scale and crop those. Remember that scaling and cropping could well be a creative decision and not just a raw technical decision. So the scaling and cropping macros form part of the IMF OPL to try and persist with the essence any of those creative decisions that need to be carried forward and put into the transcoder that actually does the actual scaling and actual cropping. After that, we encode the pixels. So there may be rules for 422 or 420 creation, depending on the output that we're trying to create. And then rules to map those into MXF using the MXF rules that basically give you the MXF picture that you can then use in your output deliverable. So the OPL, if you like, is a set of transforms that will take the original, which might be RGB 444, scale you down to 1280 720p, maybe crop to 16:9 from the original 2.35 to 1, that then encode into, for example, YUV 420, and then add the various bits of metadata so that you've got a nice compliant MXF output that can be fed directly into an output MXF file. What about audio, I hear you say? Well, audio has equivalent macros. For example, you might have a CPL with 3 different sound field groups. There might be a language, there might be a clean mix and effects. And then the goal of the OPL is to make the appropriate output, for example, a stereo mix down of the 5.1 surround and mix with the dialogue to give the appropriate stereo for the appropriate deliverable at the appropriate time. So we've now done a run through IMF. We've looked at what it is, how it works. We've used a food analogy so that you can help remember the difference between ingredients, wrapping the ingredients, finding a recipe and then baking those ingredients so that you should be able to remember the basic concepts. What is IMF? Well, it's a business-to-business format. It's not intended for consumers. It's never going to be consumer delivery. It's basically a way of representing the high-quality, file-based final master with all of its AV components, all the various versions, and all the technical metadata. And the original focus of the group was to be the grand master. In other words, here's the thing from which I'm going to make all of the children and grandchildren and great-grandchildren. And it was designed so that the thing could evolve over time. You don't necessarily make all the versions on one Tuesday late in June. You might take several years to put all of those versions together and go back and update the supplementals and keep the thing alive for a long time. It was designed to be friendly to MAMs, friendly to systems that track assets so that you can get high levels of automation, high levels of confidence, and high levels of security, reliability, and redundancy within the system. We haven't thought of all the applications yet. There are new applications coming along all the time. Some are being worked on in SMPTE at the moment in 2015. If you have applications of IMF, and if you thought to yourself, well, if only IMF did, you're probably not alone. There may be other people who want to do the same thing. So join SMPTE and help define these new IMF applications. So if that's what IMF is, what is IMF not? It was never designed as a live-to-air format. I mean, technically, there's no reason you couldn't record directly into IMF from a live ingest system and start versioning as you go, but it wasn't really designed and optimized for that. I bet somebody will do it, though. It always happens. It wasn't really designed as an origination format either. and it wasn't really designed as a delivery package to give to distribution. But most importantly, the design does not prevent it. And looking at the design and the application, it could quite well be that IMF becomes a mezzanine delivery format that allows you to target a specific territory, where you might make an IMF package for the UK, for example, or for a specific broadcast playout facility that covers certain territories. So there are certain economic reasons why I think IMF might well end up as a delivery package format in 2016, 2017. But to begin with, it's really intended as a mezzanine for in-house use to provide good versioning descriptions. And also, it wasn't originally designed for archive. But you know what? Now it exists. A bunch of people are looking at and saying, actually, archiving our different version representations, it's a lot easier and better doing it this way than it is maybe storing a proprietary, Apple XML or a Adobe Premiere project or an Avid project, because those are kind of proprietary and they won't age well, whereas IMF's a standard, and hopefully IMF will age extremely well. So if you think that IMF might be interesting to you and you want to take part, it's not difficult. I sound a bit like a stuck record, but really, SMPTE is where the action is. Joining SMPTE, participating in the standards work, you'll be one of the many studios and broadcasters, or one of the many manufacturers, or one of the many facilities that are contributing to IMF and making it actually really work and actually really get deployed and actually really turning into an application of the MXF standard that solves a real business problem that's really required today. Hopefully, we'll see you at one of those meetings, and hopefully we'll see you contributing soon. My name is Bruce Devlin. This was the IMF webinar, part of the Dalet Academy. If you like this and you want more free training, check out Bruce's shorts at the Academy. Tweet something #IMF webinar or @Dalet Academy. If you have questions, please email them to academy@dalet.com, and hopefully we'll see you at the next webinar. Thank you for listening. Thank you for watching. Goodbye.